And welcome to Naughty Notes. Well, here we're going to explore a theorem, number 10.6 in our textbook, and it has to do with the distance that a chord, in this case AB, is from the center of the circle. That distance is EF in our diagram. We'll look at it conceptually, and then my students, we're going to construct this with our compass and straight edge. So just watch this part, and then you get to use your compass. So again, a little reminder, our previous theorem told us that if we have a diameter, and EF is indeed part of this diameter, it passes through the center of the circle here, and it's perpendicular to this chord, that makes AF congruent to BF. So that's, again, that's our previous theorem. And now I want you to imagine we've got two circles. And these two circles have something in common. They got the same radius. So we're speaking to this part of the clause where it says in the same circle or in congruent circles. So in this case, we've got the two congruent circles. And I'm going to say that in that case, we can see that I've got these two chords, WX. The green chords are congruent, or the green chord is congruent to the blue chord AB. Yeah, a little trickier to see. It looks a lot easier if we just let's look at the more common case and let's say in the same circle. Now, in the same circle, I'm going to say these two chords are congruent if they are the same distance. That is, if these two are the same, then the chords CD and AB are the same. And conversely, if those two chords are the same, then this distance are the same. We can demonstrate that very easily in a single circle by rotating like this. See, they can overlap. Look at this when they become one. It's not a proof, it's a little bit of a demonstration, but you can see that it must be true. But there's no better way to get to the truth than your compass construction. So pull out that compass and let's go to it. We're going to start here. I believe I gave you a segment AB. I'm going to need this room. And I've got the associated arc AB down there. Now, if I were to draw a ray perpendicular like that, I know also by that previous theorem I could say, well, this is why it works. I know that it's going to bisect that chord AB. I know this because I've got these two are radii of the same circle. I know EF is congruent to itself, so that's going to give us a pair of congruent triangles. 1, 2, and they're congruent by hypotenuse leg. You can see that. And then I want you to we're going to draw another ray off to the side like that. And I think this is where we're going to start our construction. And that's where your worksheet starts. So let's compass swing number 1. And, oh, actually, hang on, I forgot to mention that. And of course, by CPCTC, AF is congruent to BF. Now, compass swing number 1, we're going to gap it from the center, from E to F, and give it a swing. You see what you're really making there are concentric circles. And you can say, oh yeah, that's concentric circles. Let's move our compass out of the way. So EG is congruent to EF. Now, we're going to it's going to take 3 more compass swings. We're going to construct a perpendicular to this ray passing through this given point. See, that construction never changes all the way back to chapter 3. So let's put the needle on G, open to a random arc. You want it big enough, but you can't, you got a limit here as far as you can go is E. And you're going to give this thing a swing. Remember this? Oh yeah. And all you got to do then is generate 2 intersections, one on either side of G that are equidistant. And then we're going to re-gap our compass, put the needle on one intersection, gap it to the other, like so, and you're going to gap it there, and then you're going to give it a swing. Very nice. And you know what we're doing next. Then you're going to flip your compass around, put the needle on that intersection, gap it back or confirm your gap. Oh, wait a minute, right there, and give it a swing this way. Congratulations. And you know what you've made. You've got 2 points. You've got the point G, and then you've got this intersection right there. That is the perpendicular construction for a line perpendicular to a given line from a point on that line. So I'm going to label point CD where it intersects the greater circle. And I think we're just about there. We're going to, let's put my compass away, put away my compasses. And let's see, I'm going to identify these 2 radii, EC and ED are congruent. And now I've got these 2 triangles congruent, but these 2 triangles are also congruent to these 2 triangles, all by HL. And therefore, by CPCTC again, I can say that CG is congruent to DG. By segment addition, that tells me that the 2 chords, AB and CD, are congruent. Now that's pretty cool. So fill in the blanks. And right there on your Theorem 10.6, 2 chords are congruent if and only if they are equidistant from the center of the circle. So there you have it. AB, the chord AB is congruent to the chord CD, and that's because EF and EG are congruent, those being the perpendicular distances from the center. Congratulations.